Okay, so in this video, we're going to start our very last topic of the 8 core topics, and that's going to be topic 8, which is called energy production. And so this unit is going to cover lots of interesting concepts. We'll be talking about different types of energy sources, how power stations work, types of heat transfer, blackbody radiation, the greenhouse effect, the basics of global warming, and a bunch of other things. And so more than any other unit, topic 8 really has a more global emphasis to it, and really focuses on topics that don't really belong anywhere else in mainstream physics. A lot of the concepts we'll be talking about in topic 8 are not normally taught in high school physics or even at the college level in physics, and so this is a more specialized topic. Um, uh, in other words, your IB physics textbook is probably going to be the very best resource for this topic because a lot of these things no other physics textbook is going to talk about outside of IB. Now, the topic itself is relatively straightforward, but there are going to be some new concepts and equations we'll be talking about. And as always, you'll be expected to know certain definitions and values. And so make sure you pay close attention to everything as we're going through this unit. All right, so just to give you a brief outline as to what's in this topic, in 8.1, so there's two sections to topic 8, 8.1 and 8.2. And so 8.1 we're going to do as one unit, and then 8.2 we will do as the second unit. Okay, so some of the things we'll talk about in 8.1 is we'll talk about specific energy and energy density of fuel sources, and the difference between specific energy and energy density. We'll talk about Sankey diagrams. We'll talk about different primary energy sources in today's video. We'll talk about electricity as a secondary and versatile form of energy, and then renewable and non-renewable energy sources. The things you must be able to do at the end of 8.1: you must be able to solve specific energy and energy density problems. You must be able to sketch and interpret Sankey diagrams. You must be able to describe the basic features of fossil fuel power stations, nuclear power stations, wind generators, pump storage hydroelectric systems, and solar power cells. You must be able to solve problems relevant to energy transformations in the context of these generating systems, discuss safety issues and risks associated with the production of nuclear power, and then describe the differences between photovoltaic cells and solar heating panels. Okay, and so that's just kind of give you a taste of the things we'll be talking about in this unit. Um, and this is just some general guidance, as you can see. Okay, there's only two equations in 8.1. One of them is one that you should already be familiar with, which is just the power equation. The other equation that's given has to do with wind power, power generated by wind energy, and we'll talk about that later on. I also want to point out that 8.1 has kind of topic tie-ins to chemistry and biology, as you can see down here. And so, for example, the concept of energy density is also talked about in IB chemistry in option C. All right, so let's kind of get into it today. So we're going to start off by talking about energy sources in this video. All right, and so there's two basic categories of energy sources. Okay, you have primary energy sources and you have secondary energy sources. All right, and a primary energy source is one that has not been transformed before being used by the consumer. In other words, it comes from some natural resource. And so most people, when they think of energy sources, they're thinking of a primary source. For example, coal is a primary energy source. If you have a piece of coal, um, it has to be transformed before it can be used by the consumer. Right? Holding a piece of coal in your hand doesn't really help you. Now, if you throw the coal into the furnace and it produces heat, then that heat could maybe be like a secondary source. And so a secondary source is one which results from the transformation of a primary source. Okay, so for example, like I just said, heat coming off of a fire might be a secondary source of energy. The most common example of a secondary source is electrical energy. And so when we talk about like nuclear power or wind power, all those different types of energy, ultimately what it produces is electricity, which we use in our homes. And so those other things like nuclear and solar would be primary sources, and the secondary source that we get from those things would be like electricity or electrical energy. Okay, so make sure you understand the difference between a primary source and a secondary source. I'm going to share a link with you, and it's just like a fun little website just to see how much energy you use on average in a year. You might be surprised by how much energy Texans use. But when you go to this link, you can select the state you live in, and if you select Texas, it's just like a fun visual of how much energy the average person uses in one year. All right, so just to talk more specifics about energy sources. So like I said, primary energy sources are sources found in the natural environment. And so all of these are examples of primary energy sources. Petroleum, okay, so think like oil, natural gas, coal, propane, uranium, solar, geothermal, wind, hydropower, biomass. Those are all examples of primary energy sources. Okay, sources found in the natural environment that have to be transformed before they can be used by the consumer. Okay, as opposed to secondary energy sources, like I said, electricity. Now, out of all these energy sources, which one is the best? Okay, and that's not such an easy question to answer. In fact, there's not really an answer to the question which one is the best, because unfortunately, as far as we can tell, basically every energy source has, advantages and disadvantages. And so we as a society, we as a country, and we as a global society have to weigh the costs associated with different energy sources versus the benefits. Okay, so some of the factors we use in making those decisions are the energy density of different energy sources. We'll talk more about energy density in a bit. The cost, obviously, availability, location, politics. Unfortunately, sometimes energy can become politicized. Safety concerns, environmental concerns, all of these things are really complex issues and have to be weighed in determining like what energy sources a country wants to use and how much of different sources want to be used. Okay, not to mention one thing not mentioned here is job creation, job possibility as well. Okay, so of the um, of the primary energy sources that we talked about, we can break those up into two different groups. Okay, and so I want you to pause it here and make sure you add this to your notes. As always, I want to remind you that definitions are important. Okay, but here we talk about renewable versus non-renewable energy sources, and this is probably something that you kind of know about on your own, just living in the world. But the definition of a renewable energy source is one where the energy source replenishes itself faster than it's used. Okay, it's not necessarily that there's an unlimited amount, but it can be replenished faster than it's used or continually generated indefinitely. Okay, so examples would be like biomass. When I talk about biomass, uh, bio means life, and so basically you're talking about taking matter that was alive and burning it. So, wood could be an example of biomass. Wind, solar, water, geothermal, those are all examples of renewable energy sources. Geothermal, when people talk about geothermal, they're talking about heat coming from inside the earth. And what they're actually talking about is inside in the mantle, there's a lot of radioactive elements, and those radioactive elements give off heat. And so that heat is what we refer to as geothermal energy. Solar energy we'll talk about later in this unit. There's really two ways to think about solar energy, either photovoltaic cells or solar heating panels. But either way, it's still considered a renewable energy source. And then water, you could have anything from like a water wheel to like a dam or a hydroelectric plant, stuff like that. A non-renewable energy source is an energy source which can possibly be replenished, but is likely to run out before that happens. Okay, now the actual definition, and I only tell you this because, definitions are important. Sometimes you get those definition questions on the IB exam. The actual definition is a non-renewable energy source is one in which it is consumed at a faster rate than it is produced. And so, for example, fossil fuels are being created on Earth all the time. It's just that the rate at which we use them is faster than the rate that they're being produced. Okay, so fossil fuels are an example of non-renewable energy sources, and so that this would include, oil, coal, natural gas. Okay, nuclear energy, at least nuclear fission, is also considered a non-renewable energy source because the primary fuel for nuclear power, at least today, is uranium, which there is a finite amount of uranium on the planet, and so that's considered a non-renewable energy source. Okay, so here you can just kind of see the um, the renewable versus non-renewable energy sources. Now, in this country, just to show you a few charts, in this country, you can kind of see how we consume energy. This chart goes back to 2015. The numbers are more or less comparable. Even though it's 2021, it's not too far off. We still use a lot of petroleum. We still use a lot of natural gas. The percentage of energy consumed by coal has reduced over the past few years, um, which is good because coal, even though coal, natural gas, and petroleum are all fossil fuels, coal is probably like the what they say the dirtiest fossil fuel, meaning it produces the most bad stuff when you burn it. And so the fact that our coal consumption has gone down over the past couple of years is a good sign. We have also increased the percentage of energy generated by renewables over the past few years. But you can see renewable energy, even though there's lots of different types of renewable energy, tends to be a very small chunk of the pie. Okay, and so you can look at this chart from 2015. This chart is from 2018, so 3 years later, and you can see it's changed slightly. Um, and in 2021, like I said, the percentage of coal nowadays has decreased even more. So there have been some slight changes, but still, we really like our natural gas. We really like our petroleum. If you've ever heard of natural gas, actually, sorry, I was going to say if you've ever heard of fracking, um, a lot of people have heard of fracking and how it's bad for the environment. One thing that we get out of fracking is we can actually get natural gas um, out of the ground, and so we've been consuming a lot of natural gas, more so the past few years than we did previously, um, which is kind of good because natural gas is better for the environment compared to coal even though it's still a greenhouse, even though it's still a fossil fuel and produces greenhouse gases. Okay, so moving on. So as you probably saw from the pie charts, fossil fuels are by far the biggest primary energy source used in the US. Now, when you talk about extracting fossil fuels, it's actually really difficult to do and dangerous too, whether you're talking about like a coal mine, mining coal, or like working on an oil rig. These are really dangerous types of environments because those things produce a lot of like dangerous chemicals. If you're working in a coal mine, you can get like black lung, you can get like lung cancer from the chemicals given off by all that stuff. You're working in a really like hot, dark, dangerous environment where you could have like a cave-in or whatever. And working on an oil rig is not much better. Um, the other thing about fossil fuels is that when you burn it, when you combust it, it releases carbon dioxide. And carbon dioxide is one of several gases that we'll talk about later called greenhouse gases. And basically, we'll spend more time talking about this throughout the unit, but basically what a greenhouse gas is a greenhouse gas is a gas that more or less traps heat in the earth. It's more complicated than that, and that's not a sufficient explanation, so don't be putting that on any of your like exam questions or anything like that. But that's basically what a greenhouse gas does. And so the idea is that burning fossil fuels releases a greenhouse gas and so can have a, contribution towards global warming. So that might bring up the question, why do we use fossil fuels at all if they have so many negatives? Like the biggest part of our pie is taken up by fossil fuels, and all these negatives seem pretty bad, right? So why do we use them? So let's talk about some of the advantages of fossil fuels. All right, so fossil fuels actually have a lot of advantages to them. They're very, very, very abundant on Earth. Okay, they're very easy to find, especially coal is very easy to find, not just in our country, but all over the planet. If you're a country that doesn't have a lot of resources, if you're a third world country, um, if you're a country that has a lot of poverty, coal is very easy to mine. It's cheap to mine. There's lots of it. And it's easy to use too, because, how do you use coal? I mean, basically you throw it in a furnace and you produce heat. Okay, you don't need a ton of fancy technology to do that. Okay, and so the infrastructure to use fossil fuels is also very well established. It would be difficult, on a global scale or even on the scale of the United States to kind of change our infrastructure and the way it's set up to use fossil fuels. And of course, there's lots of money to be made in fossil fuels as well, which is a factor. Now, another advantage, actually, but before I talk about energy density, um, so one thing that comes up when we talk about global warming and climate change is the fact that coal is probably like the worst thing you could burn as far as producing like dangerous chemicals and greenhouse gases like carbon dioxide. And one country that uses a lot of coal is actually China. Because China is historically been a third world country, although they've been developing a lot lately. And so their consumption of coal is way more than ours, as a matter of fact, because we are more developed as a country overall. They use more coal than we do, and so when thinking about solutions to like addressing climate change and global warming, you have to consider the fact that we can only do what we can do in our country. Whereas you have other countries all over the world, like for example China, producing a lot of greenhouse gases by burning the coal they have. And you know, what can we do in our country to get them to stop doing that? Because they have reasons why they might want to use coal. We talk about them on this slide. It's cheap, it's easy to use. You don't have to invest in a lot of expensive infrastructure or nuclear technology or anything like that. And so there are advantages to using fossil fuels, and I just want to make sure we're upfront about that. Now, the last thing I want to mention in this video is the fact that fossil fuels, aside from all those other advantages, have what's called a high energy density. Okay, and so we're not going to get to any calculation problems in this video, but I want to define what I mean by energy density, and then we'll get more into that in the next video. Okay, so here is the specific definition of energy density and specific energy. Um, These two terms are basically used to quantify how much energy can be stored in a given energy source. A lot of problems that we do in this class have to do with what's called specific energy. And specific energy is defined as the amount of energy that can be released per kilogram of fuel. So for example, if I have like 1 kilogram, so let's say the specific energy of coal is 45 megajoules per kilogram. That means if I take a piece of coal and I burn it, and the mass of the coal is 1 kilogram, I get 45,000 or 45 million joules of energy. Okay, so it's the amount of energy, either in joules or megajoules, that can be released for every 1 kilogram of that fuel. Okay, specific in science means per unit mass. And so, like when we did thermal physics, we talked about specific heat capacity. Specific heat capacity is the amount of energy it takes to raise 1 kilogram, there's that term, 1 kilogram or 1 unit mass by 1 degree Celsius. Okay, so when we say specific in science, we mean per unit mass, as opposed to energy density, which is defined as the amount of energy that can be released per cubic meter of fuel. Okay, so energy density, think like back to middle school, density is like mass over volume. And so when you talk about density in science, you talk about something over volume. Just like when you say like something is specific, you mean per unit mass. So basically energy density would be like joules per cubic meter or megajoules per cubic meter. And so when we say like fossil fuels have a high energy density, they have a high energy density. They also have a high specific energy. Those two things have separate definitions, and you need to understand the difference between the two definitions. You also have to know the units of specific energy and the units of energy density. Um, but ultimately, they measure kind of like a similar thing, basically how much energy can be stored in a given energy source. Okay, and so just to kind of show you a chart of some different specific energies and some different energy densities, you can kind of look at this chart and see, for example, like the specific energy of coal, 32, and the unit is megajoules per kilogram. So if I take 1 kilogram of coal and I burn it, or I convert it to energy, I would get 32 million joules of energy. Compare that to, for example, wood. Well, wood is like 17 megajoules per kilogram, which is not bad, but coal has a lot more. Oil has a lot more. Gas has like 3 times the specific energy compared to wood. Okay, so that's what we mean by fossil fuels having a high energy density. All right, so we're going to stop here and we're going to do some calculations with specific energy and energy density um, in the next video. One last question. I want you to look at this chart and talk about one or two takeaways or questions or thoughts you have after looking over the information on this chart. Okay, so as always, please let me know if you have any questions, and I'll see you guys in the next video.